Hello, everybody. I would like to welcome you to this session training workshop on biogas from organic waste. This is part number 5 on safety issues. My name is Jan Liebethal, and as always, you will find my contact data on the last slide in case you have questions regarding this manuscript or this presentation here. First of all, I would like to introduce the content of this presentation here. I would like to start with an introduction to safety. I would like to discuss hazards and risks, then a little bit more detailed look on hazards on a biogas plant, hazard assessment at a biogas plant, and protective measures. Last but not least, concluding remarks to round up this presentation. What is safety? Why do we need safety? Safe operation, and this is not only true for biogas plants, it's for all technical facilities. Safe operation is characterized by hazard recognition, assessment, analysis, investigation of this hazard, and active measures to minimize the risk for persons and also for the environment. Safety is not something you can do and then leave it. Safety is a process, and this includes frequent revision of the taken measures, documentation, and a lot of communication to the persons who are involved. Safety is the task of the plant operator, so it has to be organized by the plant operator. It's the responsibility of the plant operator. And any company who is coming to your plant, so external support, outside companies, they need to be instructed. It has to be checked if they are actually capable of doing the service which complies with safety standards on your side, and also, of course, standards which are in force for your country. First of all, when we start on the details of safety, I would like to give you a definition. What is a hazard and what is a risk? What is the difference between these two? A hazard is any source of a potential damage, harm, or an adverse health effect at something. This is again this environmental issue, or someone. And the risk on the other side is the likelihood that this hazard will cause essentially harm. So this includes the probability, and it also includes, of course, the severity. So taken as an example, the lightning. So the hazard which can happen to you is that you are struck by lightning and you will die from that. And the risk, the probability of this is very low because there are not many lightnings in your surrounding, in your area. But the severity at this case is very, very high, because once it strikes you, it's really a fatal effect on you. So it is just to visualize the difference between hazards and risks to you. On the next slide, I would like to introduce potential hazards at biogas plants to you. First of all, we have, of course, environmental hazards. We have health hazards. This is biological, related to biological substances and also to gases. We have hazardous substances. This can be additives to the process as enzymes or trace elements, things like that. Organic waste, components of waste materials. We also have, of course, fuel sometimes on biogas plants, or also grease on machinery, things like that. Biological agents, depending on the substances, substrates you're using. Bio-waste, for instance, can also be an issue to biological agents. Hazards from electrical equipment, this is quite obvious, I think. Also mechanical hazards, all the machinery, you can fall down from a ladder or from a platform. We have mixing devices, fast rotating machinery, things like that. GIZ hazards, as already said, within the health hazards, we also have GIZ hazards, explosion and fire hazards. This also relates to the gases available at the biogas plant or current at the biogas plant. We will discuss this a little bit more detail later on. We have sources of danger from surrounding environments. So it can storm, for instance, could disrupt your membrane roof, landslides, floods, things like that. And we have hazards arising from inappropriate behavior. And as already said, this could be not instructed personnel, contractors. This is something you have to kind of pay attention to as well. On the next slide, I would like to discuss property of gases on biogas plants. We have, of course, biogas itself. When we talk about biogas itself, it's mainly methane we are thinking of, because this is our target energy carrier. However, biogas and then also hydrolysis gases can contain other components as well. It's CO2, of course, it's ammonia, and it is H2S. Sometimes we also have hydrogen in the hydrolysis process, but this is not very often that this is apparent in high concentrations. CO2 is colorless and odorless, and it's heavier than air. So this means when it accumulates in buildings, it sinks down to the ground, and this is in danger of asphyxiation. So this is quite a difficult situation. So you have to make sure that CO2 is not accumulating in closed rooms. NH3 is a colorless gas. It is lighter than air, but it kind of irritates the respiratory tract and the eyes, and it can lead to consciousness. And in very high concentrations, it's also explosive. So ammonia is quite a dangerous gas as well if it is apparent in very high concentrations. Methane was already said. It's colorless, odorless, it's lighter than air. It has quite defined explosion range, and I will discuss this later on a little bit more detail. H2S, this is really not to be underestimated because it's highly toxic. It's also a colorless gas. It's heavier than air. It smells of rotten eggs, but only in very low concentrations. If the concentrations is above 200 ppm, you can't smell it anymore. And above 700 ppm, if you inhale in such concentration, this can lead to respiratory arrest and will cause the death of the person who is exposed to H2S. We had such accidents in Germany, so It was in a receiving pit of a biogas plant. There was quickly introduced very acid material. This led to an H2S, to a second H2S release out of this pit because the pH dropped and there was a lot of dissolved H2S in this open pit, which was quickly released. And there have been 3 or 4 persons standing right beside this pit, and they all died from this. So this is something which is not to be underestimated. We have very high H2S concentrations in biogas, sometimes up to several thousand ppm. So make sure that persons working on this biogas plant are not exposed to this. The next slide is about on this slide I would like to show you the biogas methane characteristics in regards of explosion. So the explosion hazard, which is can be characterized by certain parameters. And first of all, we have to consider that biogas contains to 60% of methane. Natural gas is almost 100% methane, but again, here in this table you have methane with a little deviation from the natural gas properties, because natural gas is not 100% methane. And last but not least, we have hydrogen here as an example, and propane. And you can see the explosion-related characteristics of these gases. And biogas contains, beside the methane, a lot of CO2, which reduces the explosion danger, I should say. So ignition temperature rises compared to pure methane or to natural gas. The flame propagation speed in air is reduced compared to the other gases. And biogas has also, compared to hydrogen, for instance, quite a narrow explosion range. And so it is an explosive gas, but it is not as active as hydrogen, for instance. So this is what you can see or derive from this comparison here. Next slide, the explosion range of methane and carbon dioxide, and the mixture of these two components into air. You can see in this triangle here, and obviously the explosion range is quite narrow, so it's not a huge range. However, as soon as biogas gets out of a closed system where you have a very high concentration of biogas and likely no air, then you can create mixtures which are within this explosion range. So as long as you have a confined system, no methane, no air in it, as pure biogas, no air in it, then there is no explosion danger. However, as soon as this gas gets into the atmosphere, as soon as this gas is mixed with air, then you have to make sure that this mixture is done without a ignition source nearby. This is a way to avoid explosion. Once you have an explosive range or an explosive mixture, then the next step would be to avoid sources of ignition, and this you can see on the right side, potential sources of ignitions, which are also at a biogas plant available. So hot surfaces, naked flames, for instance, mechanical generated sparks, electrically generated sparks, exothermic reaction, lightning strike, for instance, electrostatic discharge. So all these sources of ignition can happen on a biogas plant, and you have to make sure that if there is, at a certain point, the potential explosion ready mixture of gases, that there is no ignition source nearby. An example for such a release is a pressure relief valve. So you have an overpressure situation in your gas storage. That means your pressure relief valve opens up and biogas is released into the atmosphere. Usually these pressure relief valves, they are piped, and they have to set the gas free in a defined height in order to avoid that an ignition source can be there nearby and ignite the released gas mixture. On the next slide, I would like to show you an overview over hazards at biogas plants. By the way, most of these slides are retrieved from a publication from the Fachverband Biogas, and you can download this for free in the internet. So this brochure is, from my point of view, very informative and helps also to understand safety issues at biogas plants. Here you can see several components of a biogas plant and potential hazards which can appear at these components. To start, for instance, with the feeder at the very beginning, you can see the symbols there. The one is the explosion hazard, and the second is the mechanical hazard. Of course, the feeder has an auger or screw which transfers the substrate into the digester, and this poses a potential mechanical hazard. On the other side, the feeder is connected to the digester, and there are rare cases, but there have been cases where actually gas is diffused into the pipe, and then this gas is released in the feeder. So there is also a certain explosion hazard into the feeder. And like that, you can see all the components here, and the potential hazards which can occur at these components are stated in this graph here. Hazard assessment is essentially the tool to kind of analyze the hazard and of course also the risk of the hazard at your facility. And usually you start with a hazard assessment for a standard operation. So you assume that your plant is in normal operation, and for this situation you make a hazard assessment. However, usually at any technical facility you have specific operation states, and this could be, for instance, the startup and the commissioning of the biogas plant. It could be maintenance and repair work. Sometimes you have to shut down the plant in order to do maintenance and repair. And last but not least, at the very end of the lifetime of the plant, you have shutdown decommissioning process. And usually standard operation is quite safe, because this is what people do every day, and you know what's going on there, what's happening. And but it's has been analyzed that during specific operating states, so maintenance and repair work, for instance, or startup commissioning, that at this time most accidents happen, and most danger to the people who are working there is occurring. That's why I would like to highlight that you have to pay attention to these specific operating states. Part of the hazard assessment is also an explosion protection documentation and requirements for work equipment in hazardous areas. On the next slide, I would like to show you the process of the hazard assessment. First of all, you have to establish working areas and also tasks. So what is part of your work? What is the content of your work? And then you analyze the hazards related to these works. You determine the hazards. Then you have to make the hazard assessment. Then you have to define and establish precautionary measures. Then you have to implement them, and then you have to evaluate how effective these are. So are these measures really effective in protecting environment and labor, people? And last but not least, after this evaluation, you have to update your hazard assessment. And this is a constant process, so this is not, as already said, to be terminated or to be stopped at a certain point when you think, oh, I have now all documentation, now I can stop thinking about this. No, this is something which should be overworked from time to time. And for all hazard assessment, you need a documentation. And I can tell you, once something is happening on a facility, the only thing which is really provable is documentation. So if you have no documentation, it's very difficult to show that you have done everything according to the rules. Next slide shows the details of a risk analysis. So risk analysis is again part of the hazard assessment. It belongs to the hazard assessment. And the risk analysis puts the hazard, the likelihood of occurrence, and the potential consequences of the occurrences into a context. And according to the result of the risk analysis, you have to make sure that the protective measures have to be implemented. So the risk kind of defines how your effort to avoid these situations has to be. And make sure that this is a qualified expert who's checking on the hazard assessment and also the effectiveness of the protective measures. So this requires a certain qualification. And again, I would like to highlight that a hazard assessment must also be carried out for maintenance and repair workers before. So if you have a situation and a facility which you haven't had before, you cannot really go and start to repair or to kind of start your maintenance work. You really have to check first if what hazard is related to this work and what danger is actually posed, or what danger is, danger you're putting your employees in. On the next slide, you can see such a matrix for analyzing the risk. So this includes the potential consequences and the likelihood of occurrence. And you can see that the likelihood, of course, yeah, changes from rare over unlikely, possible, likely to almost certain. So this is very often that this can happen to you compared to very rare. Again, this would be lightning struck, for instance, always dependent on the area where you're living in, but yeah, lightning is not that often. And on the other side, the potential consequences. Yeah? And if you have, for instance, a situation where you have a not significant consequence to a person, and the likelihood of occurrence is very rare, then of course you don't have to jump into action. But you can see the more severe the consequences are, the higher the risk. And also, of course, the higher the likelihood, the more higher the risk. And the combination of these two actually results in the need for measures to avoid potential danger or harm to your employees. Now again, I would like to discuss the differences between normal operation and special process conditions. And as already said, we have the startup and decommissioning, and maintenance and repair work, shutdown and decommissioning. These are special operation conditions. And statistical evaluations of personal injuries at biogas plants. And I think this is not only true for biogas plants, but in particular for biogas plants in Germany. They have revealed that a significant higher accident rate we have connected to this maintenance and startup and shutdown procedures. I mean, we have the very specific situation in Germany that we have a lot of agriculture plants, and farmers like to repair their equipment by themselves, which is not always a good idea, and in particular not if you deal with mechanical hazards and or also explosive gases. And we had we had a few very severe accidents at biogas plants, and that's why we really emphasized during this workshop here on this fact. Make sure that as soon as your plant is out of standard operation, you're not jumping into work to restore normal operation. Make sure that you have properly analyzed the situation and start working on repair after a hazard assessment. And for this, there's a procedure. You can find this on this slide here. So first of all, you define the task or the work, and then you check, okay, is this task already part of a hazard assessment? And if you come to the decision, oh no, we have no workflow definition here, no hazard assessment, then you have to go into a hazard assessment, identify the hazard, evaluate, determine and document measures, and then you can go back to the task, and then it's not a new task, then you have a hazard assessment. If you have already a hazard assessment here, then you should check if this is really effective here, this works, and the situation, the hazard assessment fits the situation, then you can perform the work. And again, we had the discussion previously. There is if there is a new hazard or a new situation showing up, you are going back to the situation that you have to check on the hazard assessment. So always when you are at work, and sometimes repair and maintenance can lead to new situation, make sure that you are checking on if any measure is here appropriate, if the situation is under control. And if not, then you have to step out and make a hazard assessment again. And it's very important that this is not only true for personnel on site, but also for external people. Sometimes they are not really, they do not really know the details of the plant. They are not very familiar with the situation of a biogas plant. So make sure that you have also external personnel within this process. Next point is the explosion protection documentation. The explosion protection document is part of the hazard assessment. Explosion is quite a severe hazard, and that's why this requires an extra documentation. And it contains identification and evaluation of explosion hazards. So first of all, you start to think of where explosive atmosphere or potentially explosive atmosphere can be expected, and you relate that to potential ignition sources. So can in this area also be ignition source. So this would increase the likelihood of a dangerous situation. Protection against such dangerous situation is threefold. You start with a primary structural measure that prevent hazardous explosive atmospheres. So make sure that your system is gas tight, for instance. Secondary, you have technical measures in case that a hazardous explosive atmosphere is unavoidable. So that would be, for instance, the outlet of the overpressure relief valve, what I already discussed. And then the secondary technical measures are aimed at avoiding creation of ignition sources, so that your potential explosive atmosphere is not nearby ignition source. And the third protection measures, tertiary or organizational measures, are aimed at reducing the potential consequences of an explosion. That would be, for instance, open construction of around facilities, that in case of an ignition and an explosion happen, that the building is not being destroyed, so that the pressure caused from the explosion can freely get out of the building, for instance. These are organizational measures which aim at reducing the potential of consequences of explosions. The explosion protection documentation includes also a classification of zones, and this is how the likelihood of an explosive atmosphere is in this zone. This is how these zones are classified. We have 3 types of zones, and the one is zone number 0, This is an area in which hazardous explosive atmosphere is very likely to occur. So this is either it's continuously for long periods or frequently. So it's simply very often that you have explosive mixtures there. Zone number 1, this is a mixture of air or combustible gases can likely occur in normal operation. And zone number 2 is really rarely or only for a very short period of time occurs. Examples at biogas plants, zone number 0 is actually only inside some technical, if you have a CHP, for instance, inside the CHP, of course, you have a mixture of biogas and air, but outside there's actually no zone where you have continuously explosive mixtures. Zone number 1, occasionally in normal operation. Again, we have here the outlet of the overpressure valve as an example, where the gas is released, and you have, of course, at the top of this pressure relief valve, explosive mixtures. And zone number 2, examples here are, for instance, the air cushion of air-inflated double membrane. So if you assume a leak in this membrane and then it releases biogas into the air cushion of the air-inflated double membrane, then an explosive atmosphere can build up in this gas dome. According to this zone, once you have defined these zones for your facility, the equipment needs to be licensed, certified to be applied in this respective zone. So the technical equipment, motors, whatever you have in this zone needs to be certified in order to avoid, for instance, ignition sources coming from this equipment. And this is, of course, very important to your operation and also to your technical measures at your facilities. Where do you define these zones? Measures to prevent explosions are again threefold. You have, first of all, the measure to prevent formation of explosive atmospheres. Second is prevention of ignition. Part of this is this X zoning, what I already said. You also can prevent sources of ignition. You can have also organizational measures to avoid ignition. Example here is, for instance, no smoking rule in biogas plants or anti-static work wear. And the third protection is what I already said, reduction of explosion consequences. So you have personal protective measures, explosion suppression, explosion pressure resistance, or evacuation or distance. Once you recognize, for instance, on a plant that there's a situation, a lot of gas is released, then you would evacuate, of course, the plant and make sure that people are not inflicted by potential explosions. Examples for prevention of formation of explosive measures are also, for instance, forced ventilation in CHP containers with a high enough air change rate in such a container. You can avoid that even with a large leak. Explosive atmospheres can build up in enclosed rooms. Gas concentration monitoring is also a way to check upon explosive measures. And very simple measures, installation of components outside. So if you have gas transporting components or valves, things like that. If you have them outside, if there is a leak, the dilution rate is that high that the danger of explosion is much lower than in a closed room. On the next slide, you find here you can see an X-zone plan, and obviously the zone number 1 is defined as nearby the overpressure relief valves. You can see that in these two examples here, that these zone number 1s in red in both plans are related to the overpressure relief valves. In the right plan, there's also the torch given as a zone number 1 here, because if you think of the torches not functioning properly, then also their gas can be released into the air, and then you would have a very similar situation to overpressure relief valve. And zone number 2 is around these zone number 1s, because there you can have occasionally also explosive concentration. So the area of zone number 2 is larger than the area of zone number 1 here. Now I would like to discuss protective measures, and these protective measures again have a threefold hierarchy. First of all, you have to actually do technical protective measures. This is technically to avoid dangerous situation by, for instance, gas warning devices, ventilation, protective covers for rotating parts, or have a closed metering station for process additives, so that the hazard and the risk are minimized as much as possible. Second step would be organizational protective measures. This is work instructions. Of course, you can imagine if you instruct your personnel, they should follow these instructions, and if they know the danger, they can avoid it. But still, you never know, human failure on early morning or late afternoon, people might not pay that attention as they should, and then work instruction wouldn't be that effective as a technical protective measure, for instance. Briefing, besides the work instructions on specific procedures, emergency plans, on-call service. You have to carry out inspections and tests, and requirements, of course, for lone working is a very important part. And also, what is very important is that if you have a responsible person on site, make sure that you have a substitute for this, and the substitute is briefed and instructed in the same way, because it can happen that you have a hazardous situation on site and the instructed and responsible person is not available, or is involved in an accident and is not able to actually carry out safe operation. Then somebody else has to be able to take over here. And last but not least, personal protective measures: gloves, work clothing, respiratory protection, safety shoes, safety glasses, depending on the work you are doing. Fire protection concept follows very similar concept. So consider national regulations, of course, they can differ in each country. The fire protection concept includes structural fire protection, organizational fire protection, and then of course the protective measures, again we have organizational protective measures and personal protective measures. Looking at protective measures a little bit more into detail. So the operator should design and document the plant's organizational structure in a way that all activities and tasks can be safely performed and monitored at all times. The following arrangements should be made at the very minimum. This is responsibilities. So who is responsible for what? Checking, operating log, carrying out instructions, briefing, performing the hazard assessment. The employer can delegate the task to employees, but make sure that the person is qualified to do that, has also a standing within the company and allowance actually to do measures. So the position in the company shouldn't be too low, because then it's not very likely that they can carry out this task. Deputization, what I already said, arrangements and substitution plan in case the person who is responsible is not available. On-call service, something which is important, and assignment to the right to issue instructions. Somebody has to take the responsibility, and this person also needs to be allowed to stop operation, for instance, if the maintenance, as an example, is not carried out in a safe way. Then it's important that there is a person who's saying, stop doing this now, because this is a dangerous situation. Protective measures, operating instructions. The plant manufacturer should give any operator a thorough briefing, but at the end the operator is responsible for the operation, so the operating personnel of a biogas plant should take part in further training and continuing professional development and certificates. Again, I have highlighted that several times now in this presentation. I would like to highlight this again. Make sure that external companies know what they are doing on your plant, and if they are really competent to work on a biogas plant. Instructions include safety and health at work, descriptions and highlighting of work areas where explosion hazard can be expected. Then, of course, every company has internal company instructions about health and safety. And also make sure that you discuss hazardous substances which are present or might arise at the workplace. In particular, here we need to discuss hygiene regulations. Some waste-related biogas plants have an area where waste contact area is separated from outside areas, so-called black and white deviation or distinguishing. Information about measures to be taken to prevent exposure to hazardous substances, for instance. Information about wearing and using personal protective equipment and protective clothing. On this slide you can see personal protective equipment. This is options you have when working at a biogas plant. I would like to add here maybe the air protection or air supply system when you go inside a digester, or if you open up a digester, then you have to make sure that you have external air supply and a according mask. But other than that, you can see safety shoes, catching systems in case you go on a platform or you go on a biogas digester roof, things like that. Hearing protection when you go inside CHP containers. For protective measures, on this slide you find some examples. Hazardous substances, for instance, as microorganism aerosols or biogas itself, additives on biogas plants, then you have to make sure that you protect your eyes. Respiratory protection, what I said on the slide before, you have to really check on where this is necessary. Filter mask might help if you use, for instance, additives where the inhalation of dangerous substances is threatening, so then you need to use a filter mask. If biogas is released, then you need to have a closed circuit self-containing breathing apparatus. This is this air supply, external air supply, what I already mentioned in the slide before. And yeah, in particular when high concentrations of H2S can be expected, then it's of course a very dangerous situation. Electrical hazards, again, safety shoes are a way here to protect yourself from defective cables or static discharge. Mechanical hazards, they are not to be underestimated. Falling, stumbling, but also not trying to repair feeding hoppers by yourself, going into the hopper and, for instance, removing parts which have been stuck in there. So we had fatal accidents in Germany caused by such activities of plant operators. So stay away from these large machinery if you're not comfortable with repairing them and if you have not the proper education to do so. So this is quite dangerous work you can do there. On this slide you find a list of components or equipment which requires specific conditions, specific measures. I don't want to discuss them all here quickly. You find in this publication which I mentioned examples of specific requirements for components. For instance, here I have taken out one example. This is an overpressure relief valve, and here you find the requirements for these pressure relief valves. I don't want to discuss this here now in detail. I think this is very specific points here, but just to make sure that you have seen this once in order to understand what is required for most of the components at the biogas plant in order to avoid accidents and to avoid hazardous situation to the personnel. Last but not least, Inspections and tests. This is the continuous process where I was talking about prior to the slide here. And this is also, this has a certain frequency. So you have to test objects and processes. Objects are, for instance, fire extinguishers, which you have to test, or safety equipment, protection systems, but you also have to test if you still comply with regulation, for instance, water legislation, or if certain processes are still in compliance with regulation. But you also have to test your electrical equipment, pressure vessels. So depending on the object and the segment or the area on your facility, so areas means structural safety or explosion protection, pressurized system, electrical installations, functional safety, fire protection, all these areas, and of course the objects which I was relating before, this has to undergo a certain revision in a certain frequency. And in this table on the left side here, you can see that these frequency is not the same for all objects or processes. So, but you have to do this in a certain period in time in order to update the systems, to make sure that your safety measures are still valid and functioning, and you protect your employees properly. To conclude, what is the take-home message of this workshop here? Safety is a constant process. It's not, I've said that several times, but it's not that you are done with this. At a certain point of time, you have to do this continuously. Biogas plants have a variety of potential hazards which need to be paid attention. Statistics show that special operational conditions are most dangerous. So normal operation is usually under control, but special operating conditions are very often quite dangerous. Training and instruction of personnel has to take place frequently. And of course, whenever somebody external enters your plant, make sure you brief them, make sure you give them instructions, and make sure that you check if they know what they are doing here, because you don't want to put your own plant into jeopardy with unqualified contractors. Thanks a lot, and you find my contact data on this slide as said, so if you have questions, feel free to address them to me.